In today's video, we are going to be taking a look at how the radius of an ion compares to the radius of the atom. But before we do that, we need to review some bonding rules. Our next unit will be bonding, so we'll be going into way more detail in the next unit, but we just have to talk about some general stuff first. So, atoms will react to get a full valence shell. So that's very important. So what we want to do is we want to look at the elements' electron configuration, specifically paying attention to valence electrons. And then we want to think about how the atom is going to get to a full valence shell, which would be 8 valence electrons. So what I mean by take the shortest route to get to 8. If we take a look at bromine, bromine's electron configuration is 2, 8, 18, 7. So in order to get a full valence shell, in order to get to 8, it just needs to gain 1 electron, meaning it would make a negative ion. So as we'll see when we start talking about ionic radius, since bromine gains an electron when it reacts, the radius of the bromine ion would be larger than the bromine atom. Another way to look at it is they want to have the same electron configuration as the closest noble gas. So noble gas is group 18. They are stable because they have a full valence shell. So the atoms will react to get the same electron configuration as the closest noble gas. All right, so we'll take a look at barium now. Barium's electron configuration is 2, 8, 18, 18, 8, 2. So if we do the closest noble gas, so barium is atomic number 56. The closest noble gas is xenon, Xc. So barium will lose these 2 valence electrons. So it will lose 2 valence electrons to make the barium plus 2 ion. So the barium ion will be smaller than the barium atom because it loses 2 electrons. All right, let's take a look at nitrogen. Nitrogen is 2, 5 for the electron configuration. So we have 5 valence electrons. So in order to get a full shell, it could either lose 2 to end up like helium or gain 3 to look like neon. So gaining 3 is going to be the shorter route. So nitrogen will gain 3 electrons to make the N3 minus ion. So the nitrogen ion would be bigger than the nitrogen atom, the radius would be. The mass would not change since electrons are essentially massless. All right, next example is rubidium. Rubidium is 2, 8, 18, 8, 1. So rubidium has 2 choices. It could lose 1 electron. That would give it the same electron configuration as krypton, or it could gain 7. So losing 1 is going to be the much shorter route. So it will lose 1 electron to make Rb with a positive charge. So we would expect the rubidium ion to have a smaller radius than the rubidium atom. All right, last example is lithium. Lithium's electron configuration is 2, 1. So lithium has 2 choices. It can lose 1 because then the first shell is full with 2 because the first shell can only hold 2 electrons. So lithium could lose 1 electron to have the same electron configuration as helium, or it could gain 7 to have the same electron configuration as neon. Losing 1 is quicker, so it will lose 1 electron to make the Li plus 1 ion. So we would expect lithium to have a smaller radius, the lithium ion to have a smaller radius than the lithium atom would. So again, our ionic radius is the radius of an ion, and we get an ion by losing or gaining electrons. So you have to look at the electron configuration and remember that when atoms react, they want to get a full valence shell, which is usually 8, unless they just have one valent, or unless they just have one electron shell, then it would be 2. Or they want to react to look like the closest noble gas. So with sodium, sodium's electron configuration is 281. So sodium will lose an electron when it reacts to be 28, and this would have a smaller radius. Normally in my PowerPoint, it actually shows the size of the atom decreasing, but unfortunately the animations don't work with my screencasting program. So metals will lose electrons when they react to form positive ions. So an ionic radius for a metal will be smaller than the parent atom that it came from. For example, the sodium ion would be smaller than the sodium atom because it will have one less electron shell. All right, so now we'll take a look at our nonmetals. So if we look at chlorine, chlorine's electron configuration is 287. So when chlorine makes an ion, it is going to gain an electron to become 288 to get a full valence shell. So then the chlorine ion would then have a larger radius because it would have more electrons with the same number of protons, and the electrons will repel each other a little bit, so that last shell will puff out to accommodate the extra negative charge. So our nonmetals tend to gain electrons to form negative ions, so their radius will increase. So nonmetals, since they gain electrons, their ions will have a larger ionic radius than the atom that they came from. All right, so now we just have some example questions. So which particle has the smallest radius? So we can do this with trends, or we can take a look at the periodic table. So let's first just compare sodium versus potassium. So sodium has 3 electron shells, potassium has 4 electron shells. So that's going to make sodium smaller. Then if we're comparing sodium versus the sodium ion, sodium would have 3 electron shells. The sodium ion would just have 2 electron shells. So that is going to be smaller. Now, you will never have to actually report the radius of an ion. For example, on table S, the radius of our atoms are listed. So we could look up that sodium would have a radius of 160 picometers. We just know the ion would be less than that. You wouldn't be required to say what it actually is. All right, number 2, which ion has the largest radius? All right, so what we want to do is think about how many electron shells they each have. So sodium would be 281, but the ion would just be 28 because it would have lost an electron. Magnesium atom would be 282, but the ion would just be 28 because it would have lost 2 electrons. The potassium ion, or potassium atom, would be 2881, but the ion would have lost an electron to be 288. And calcium would be 2882, but the +2 ion would have lost 2 electrons to be 288. So 2 of our choices have 2 electron shells, 2 of our choices have 3 electron shells. So the ones with 3 electron shells are going to be larger. Now our tiebreaker is protons. Potassium has 19 positive protons. Calcium has 20 positive protons. Calcium ion is going to be smaller because it has a stronger nucleus pulling in the same number of electrons. So that means the potassium ion is going to be the largest because it's got 3 electron shells, but has less protons, so it's not as able to pull in those electron shells. So there's not as much attraction between the nucleus and the 18 electrons. All right, question number 3. What happens to the S atom when it becomes S minus 2? So if we have a -2 ion, we are gaining electrons. And if we're gaining electrons, we would anticipate the radius increasing because there's going to be more electrons with the same number of protons. So the electrons are going to repel each other and the radius is going to get larger. It's going to puff out, take up more space. All right, again, we're looking for the largest radius. So we have the sodium atom, and we could actually look up that radius on table S. We have the sodium ion, which would only have 2 electron shells because it would have lost an electron. And we have chlorine, 287. Okay, so we cross off the sodium ion. That only has 2 electron shells, so that would be the smallest. Sodium, chlorine, both have 3 electron shells. But chlorine has more protons, so chlorine can pull the electron shells in tighter, so that would leave sodium to be larger. Plus, we also could have looked this up on table S and seen that sodium atom has a radius of 160 picometers, while chlorine has a radius of 100 picometers. So table S can help us out too. Number 5, which of the following elements has an ionic radius smaller than its atomic radius? So we are looking for something that will lose electrons when it reacts. So we are looking for a metal. Or you could do it by the electron configuration. So it's not going to be neon. That's a noble gas. It's already got 8 valence electrons, so it's not going to form an ion, or at least readily form an ion. Nitrogen has 5 valence electrons, so it will gain, so that will get larger. Sodium has 1 valence electron, so that will lose to get smaller, so that's going to be our answer. Sulfur would have 6 valence electrons, so that will gain 2 to get to 8, so that would get larger too. Last question. The sodium ion has a smaller radius than the neon atom, even though they both contain 10 electrons. So sodium is 281. The sodium ion lost an electron to become 28. Neon is also 28. So they have the exact same electron configuration. They both contain 10 electrons. However, the sodium ion has 11 protons. Neon has 10 protons. So the sodium ion has a greater attraction to the electrons because it's got a stronger nucleus, so it can pull those electrons in tighter. So we'll just write that. Na plus has a greater attraction. Oh, I'm going to run out of room, so I'll just have to say it. The sodium ion has a greater nuclear charge, so therefore it will have a stronger attraction between the nucleus and the electron, so it will pull the electrons in tighter.